Hello everyone and welcome back to Vidyarthi Point. So, after learning the concept of boats and streams and the formulas, let us apply those formulas and solve some examples. Before that, I am going to do a quick recap of the formulas that we have learned in the previous video. Number 1, speed of boat downstream indicated by ds, which is equals to speed of boat in n plus speed of the current. This is the formula for downstream speed. Again, next we have speed of boat upstream, which is denoted by us equals to speed of boat minus speed of current. So, this is the formula for the upstream speed. Now, speed of boat in still water, that is bs equals to downstream speed plus upstream speed divided by 2. This is the formula for speed of boat in still water. And then we have speed of river or current, which we indicate by cs, which is equals to downstream speed minus upstream speed divided by 2. Also, we have to always keep in mind that speed of boat is always greater than the speed of the current. Now, let us solve some examples. Now, let us solve the questions. Question number 1, we have here, a man can row 16 km per hour downstream and 6 km per hour upstream. Find the speed of boat in still water. Here, we can use the direct formula of speed of boat in still water. We know the formula is bs, that is speed of boat in still water is downstream speed plus upstream speed divided by 2. Here a man can row 16 km per hour downstream is given. So, his downstream speed is 16 km per hour. Upstream speed, from the question we know that he can row 6 km per hour upstream. So, upstream speed is 6 km per hour. Now, we have to take these values and put it in the formula. Downstream 16, upstream 6 whole divided by 2. 16 plus 6, we will get 22 divided by 2, that is 11 kilometer per hour. So, the speed of the boat is 11 kilometer per hour. Now, let us look at question number 2. Here we have the data, that is upstream speed equals to 8 km per hour, downstream speed equals to 16 km per hour. Find the speed of current. Here similarly, like the previous question, the boat can row 8 km per hour upstream and 16 km per hour downstream. Here we have to find the speed of the current. In the previous question we have found the speed of the boat. Here we have to find the speed of the current. So, here we can apply the direct formula, that is speed of current Cs has a direct formula, which is downstream speed minus upstream speed divided by 2. Now, from the data we have upstream speed equals to 8 km per hour. Now, downstream speed is 16 km per hour. So, we are going to apply the values in this formula. Downstream is 16, upstream is 8 divided by 2. That is 16 minus 8, it will be 8. Now, upon cancellation, we have 4 km per hour. So, by applying the formula, we found the value of the speed of current, which is 4 km per hour. Now, let us look at question number 3. A boat is rowed down a river 30 km in 6 hours and up a river 15 km in 5 hours. Find the speed of boat and current. In this question, we have to find both the speed of the boat and current. Here, A boat is rowed down a river. That means this is the downstream speed which is given 30 km in 6 hours. In this chapter, we have to apply the formula of speed, distance and time. The formula and the concept of speed, distance and time is clearly explained in our previous videos. If you have any confusion, please go through that video. Now, we know the formula as speed equals to distance by time. Now, a boat is rowed down a river 30 km in 6 hours. 30 km is the distance, 6 hours is the time. We have to find the speed. So, downstream speed will be distance which is 30 km and time which is 6 hours. 6 5 ja 30. So, 5 km per hour is the downstream speed here. Now, and up a river 15 km in 5 hours. Using this formula, upstream speed we can find here. Distance is 15 km. We have to write 15. Time is 5 hours. Here we have to write 5. So, 5 3 ja 15. Like 6 5 ja 30. Here 5 3 ja 15. So, 3 km per hour is the upstream speed. Now, here we have to find both the speed of boat and the current. Here also we will apply the direct formula. So, speed of boat, the formula is downstream speed plus upstream speed divided by 2. Here, downstream speed is 5, upstream is 3 divided by 2. So, 5 plus 3 is 8 by 2 is 4 km per hour. This is the speed of boat. Now, speed of current. Here also we will apply the direct formula. Speed of current is downstream speed minus upstream speed divided by 2. Downstream speed is 5 minus upstream speed is 3 divided by 2. 2 by 2 upon cancellation 1 km per hour. So, speed of the current is 1 km per hour and speed of the boat is 4 km per hour. That is 2 upon cancellation 4 is there. Now, let us look at question number 4. A man can row 6 km per hour in still water. When the river is running at 1.2 km per hour, it takes 1 hour to row to a place and back. How far is the place? In this question, here we have to find the distance. A man can row 6 km per hour in still water. That is, this is not the downstream or the upstream speed, but this is the speed of the boat in still water. That is, here speed of boat in still water is given, which is 6 km per hour. When the river is running at 1.2 km per hour, that means this is the speed of the current, which is 1.2 km per hour. Now, using these values, we have to find the speed downstream and speed upstream. We know that downstream speed according to formula is speed of boat plus speed of current, which is 6 plus 1.2 equals to 7.2 km per hour. Now, similarly, upstream speed is speed of boat minus speed of current, which is 6 minus 1.2, which is 4.8 km per hour. Now, we know the speed of both, speed of current, downstream speed and upstream speed. Also, in the question, it is given that it takes 1 hour to row to a place and back. How far is the distance? So, here we got the speed. From the question, we know that the time is 1 hour. In that 1 hour, the man has covered the distance once rowing downstream, then again upstream. Let the distance be x. We know that speed equals to distance by time. Also, if we cross multiply, time equals to distance by speed. Here we know that the time is 1 hour and upstream, let the distance be x and upstream speed is 4.8. Similarly, the time is 1 hour, distance is x, downstream speed is 7.2. These values we have to put here. Distance by downstream speed plus distance by upstream speed equals to 1. I am going to repeat this again. Here, a man can row 6 km per hour in still water, whereas the river is running at a speed of 1.2 km per hour. It takes 1 hour to row to a place and back. 1 hour, the time, row to a place and back. That means downstream, then again back, that is upstream. Now, we have to simplify this. Here, we have to take the LCM of these two. Let us keep it as 7.2 into 4.8. This will be their LCM. Now, here we will 7.2, if we divide this, we will have 4.8x, and here if we divide this by this, we will have 7.2x equals to 1. Okay, now cross multiply this. 4.8x plus 7.2x. 4.8 plus 7.2, this will become 0, 1 is remainder, 4, 5 plus 7, 12. So, this will become 12x. Now, the denominator which was supposed to come here, we will cross multiply it, that is 12x equals to 7.2 into 4.8. Now, again this 12 will come as the denominator, that is x equals to 7.2 into 4.8 divided by 12. Now, we have to divide these two by 12. Now, 4.8, if we divide by 12, we cannot divide 4 by 12, so 0 will come here, 4, then this point will go here and 8 will come down. We have 48, 12 4s is 48. So, 12 into 0.4 will give us 4.8, 12 into 0.4. Now, we have to find the value of x. X will be 7.2 into 0.4, that is 7.2 into 0.4. 4 2s are 8, 4 7s are 28. This will come here. Since there is 2 decimal points, so 2.88. So, distance is 2.88 kilometer.